Let's go ahead and try to do graphing another way. I mean, by other way, it really indicates that there's all kinds of ways to do graphs. We just got finished in the last section taking a look at just actually solving for a bunch of ordered pairs and plotting those. This time we're going to solve for particular ordered pairs called intercepts, and go ahead and use those intercepts as specific solutions to go ahead and find the graph of this equation. And that graph of any equation really represents all the possible solutions. But here we're specifically looking for intercepts and then one additional point called a checkpoint, which we'll talk about here in a minute. So let me just go ahead and take a look at this problem right here. And let's see how we could go ahead and find the intercepts. Well, by intercepts we mean where does this line cross the x-axis, and that point would be called the x-intercept, and where does it cross the y-axis, and that would be called the y-intercept. Well, when a line crosses or a point is found on the x-axis, its y-coordinate is 0. So the way we're going to go ahead and find the x-intercept is to go ahead and put 0 in for y into the equation. We're going to go ahead and let y equal 0. So we're going to go ahead and really say that we have 2x minus 3 times 0 is equal to 6. Or, since this turns out to be 0, we'll get 2x minus 0, or I'm just going to not even write that, equals 6. Divide by 2. And our y-intercept, the coordinates of it would be, this answer is 3, x is equal to 3, so our point is 3, 0. That's our x-intercept. Our y-intercept would be to go ahead and let x be 0, because when we're on this x-axis, we're going to go ahead and really have a point there where the y-coordinate, I'm sorry, the x-coordinate is 0. So for the y-intercept, I'm going to let x equal 0. And that means I'm going to get 2 times 0 minus 3y is equal to 6. So I'm going to go ahead and solve this here. 2 times 0 is 0, so I'll get 0 minus 3y, or just negative 3y equals 6. I'm going to divide both sides by negative 3. And y is equal to negative 2. So my ordered pair that represents my point at which I'm crossing the y-axis is at 0, negative 2. Now that's 2 points I have, 2 solutions. And they're specific ones called intercepts. That's what's unique about this section 3.2 is graphing by intercepts. So I could put 3, 0 here and 0, negative 2 here. And I could draw this line, but I want to make sure I didn't make any mistakes, and that is where the checkpoint comes in. And this checkpoint is important, but it is somewhat random in that it doesn't matter what other point I solve for. It should be a point that is collinear with this if I've done a good job in finding those intercepts. So the way you find a checkpoint is just randomly picking a value to go ahead and put in for x or y, solve the equation, graph that point, and make sure that it checks out as a line that goes through all 3 points, the 2 intercepts and the checkpoint. So here we go. Let's find a checkpoint here. And I am just randomly picking a value. You could pick any other value, and we could all find checkpoints that should be solutions to the equation. But I'm going to put a 1 in here. So if I put a 1 in for x, I'll get this equation. And I'll get 2 minus 3y is equal to 6. I'll subtract 2 from both sides. And I get negative 3y is equal to 4. I'm going to divide by negative 3. And I get kind of an odd value. I get negative 4/3, which when I go to plot would be kind of difficult, so I'll just convert this. This is y is equal to negative 1 1/3. Mixed numbers might be a little easier for me to graph. So I just found a third point. It is x coordinate of 1, y coordinate of negative 1 and 1/3. So my third point that I'm calling the checkpoint to make sure that, and check that the other 2 points, which were the intercepts, were valid solutions. I did a good job with them. Let's see if this is collinear with these points, meaning it ends up on a straight line with those 2 points. So this is 1 and negative 1 and 1/3, and here's 1, and negative 1 and 1/3 looks right. So not only does my checkpoint line up with these 2 points line up with my checkpoint, and overall I'm feeling comfortable that I did a good job of graphing this by intercepts. So I really want to emphasize the importance of using that checkpoint. And by the way, a checkpoint is that very thing, a check. So you don't want to go ahead and just randomly, after you craft your intercepts, throw another point on the same line that goes through the intercepts. That is the very opposite of an independent check. You want to independently calculate this, not just plot it on a point that, on a line that already goes through the intercepts, right? That's not really a valid way of checking that you did a good job with your intercepts.